Hello, everyone. So last time we were looking at first order differential equations, and in particular, linear first order differential equations. Last time, linear first order ODEs of the form, the equations of the form y prime plus p of x times y equals f of x. And we used the integrating factor which was a function of the form r of x equals e to power integral p of x dx. And why did we use this integrating factor function? We used it in order to make the left-hand side as the whole derivative of another function. We use the integrating factor in order to make the left-hand side a function, the left-hand side as derivative of another function, namely derivative of basically r of x times y. We chose r of x properly this way so that left-hand side becomes derivative of r of x times y. So if I want to explain about the steps of solving a linear first order differential equations, so they will be as following. So the steps for solving a linear first order ODE will be as follows. So step one, first we need to find the integrating factor. Find the integrating factor. R of x equals e to power integral p of x dx. And step two, write the given ODE in the form d to dx of r of x times y equals r of x times f of x. And this means that r of x times y equals integral r of x times f of x. And then complete the integral on the right-hand side, the right-hand side integral. And solve for y. Okay, these are the steps that you can follow in order to solve the linear first order ODE. Now let's look at an example. Solve y prime plus 2x times y equals e to power x minus x squared with y of 0 equals minus 1. So here our p of x, if we compare it with the general form of linear first order ODE is y prime plus p of x times y equals f of x. Now P of X here is 2X. P of X is 2X. So R of X, the integrating factor, we have the formula for integrating factor is e to power integral P of X dx. That's going to be e to power integral 2x dx, which is e to power x squared. Well, you could tell me here that, integral to x dx is x squared plus c. Indefinite integral to x dx is x squared plus c. But in the context of integrating factor, we can choose that c to be 0 because we are looking for one integrating factor. We don't have to find all integrating factors, right? We just want to find one integrating factor that works. So of course, it's the easiest choice for c is 0. And then we will have one choice for our integrating factor, which will be e to power x squared in this case. And then we will have d to dx. So what was the next step? So the equation, our equation can be written as pencil, still not writing. So our ODE can be written as, what was the form after we use the integrating factor? Then we can write it as d to dx. R of x times y equals r of x times f of x. So d to dx r of x times y equals r of x times f of x. So that means d to dx r of x was e to power x squared times y equals e to power x squared times f of x. What was f of x? F of x is a function in the right-hand side, which is e to power x minus x squared. So I can also write f of x here. F of x is e to power x minus x squared. So e to power x squared times e to power x minus x squared. So that means d to dx of e to power x squared times y equals e to power x. E to power x minus x squared times e to power x squared is e to power x. Now integrate both sides. Then you'll have e to power x squared times y equals integral e to x dx, which is e to x plus c. And now if I multiply both sides by e to power minus x squared, right? See, we're almost done here. Instead of finding y, my goal is to find y. Instead of finding y, I already found y times e to the x squared. I just need to divide both sides by e to the x squared in order to find y. So I multiply both sides by e to power minus x squared, then I'll have y equals e to power x minus x squared plus c times e to power minus x squared. And we just need to find this constant c. How do we find the constant c? Of course, using the initial condition. Lastly, find the constant c above using the initial condition. What was the initial condition? Y of 0 equals 1. Y of 0 equals minus 1. Y of 0 equals minus 1. So y of 0 will be e to power 0 minus 0 plus c times e to power 0. that is supposed to be -1. That gives 1 plus c equals -1. This gives the value of c to be -2. So substitute back. And then we'll have y equals e to power x minus x squared. It's plus c times e to power minus x squared. C is -2, so -2 times e to power minus x squared. This is the final answer for our ODE, e to power x minus x squared minus 2 times e to power minus x squared. Of course, if you want to be sure that your calculation was correct, you can verify your solution by, first of all, you know that your solution must satisfy the equation. So you can find y prime and then find y prime plus 2x times y, do the calculation and see whether you get e to power x minus x squared. So y should satisfy the equation, and it also should satisfy the initial condition, meaning that y of 0 must be -1. And that is very easy to verify. Y of 0 is e to power 0 minus 2 times e to power 0, which is 1 minus 2, and that's of course -1. So that's the initial condition is very easy to verify, but you can also verify the ODE if you want to be sure that your calculation is correct, or if you want to verify your solution, basically. All right, let's look at the next example. Solve y prime plus cos x times y equals cos x. Well, again, this is a first order. The equation above is a first order. It's first order because the highest derivative appeared is y prime, and it's linear. All the powers of y and y prime are 1. The equation above is a linear first order ODE with p of x here is cos x, and f of x is also cos x, because we are comparing it with y prime plus p of x times y equals f of x. So the integrating factor, you just need to follow the steps that we just explained for solving linear first order ODE. First, we need to find the integrating factor r of x. Integrating factor will be r of x equals e to power integral p of x dx, which will be e to power integral cos x dx, and that's e to power sine x. So this is r of x e to power sine x. Then we can write our equation in the form d to dx of r of x times y equals r of x times f of x. So that means d to dx of r of x is e to power sine x times y equals e to power sine x times cos x. And now integrate both sides. I'm just following the steps. First, we found r of x. Then after finding r of x, we can write the equation as d to dx of r of x times y equals r of x times f of x. And that gave us d to dx e to power sine x times y equals e to power sine x times cos x. And now if we integrate both sides, then we'll have e to power sine x times y equals integral e to power sine x times cos x dx. And that gives y times e to power sine x equals Well, for this one, to calculate this integral, I can call sine x, call it t, for example. Then I'll have, then dt will be cos x dx. Just using substitution. Finding integrals using substitution. It's a very basic method you learned in Math 114. Then you'll have integral e to power t dt, which is e to power t plus c. See, sine x, I called it t. Cos x dx will be dt. Integral e to power t dt will be e to power t plus c. And t is sine x, so this is e to power sine x plus c. And therefore y will be equal to, if I multiply both sides by e to power minus sine x, then y will be equal to 1 plus c times e to power minus sine x. Do we need to find c? Well, let's look at the question. To find c, we need the initial condition. The initial condition is not given in the question, so we don't need to find c. We can just leave c as it is. And we can call this the general solution of our ODE. Now, if the initial condition was given, we could find c, but initial condition is not given, then that means we need to leave c as it is. Now let's look at an application of this linear first order ODE. Let's look at an application which is about concentration of chemicals in bodies of water. So the question says 100-liter tank contains 10 kilogram of salt. 100-liter tank contains 10 kilogram of salt dissolved in 60 liter of water. Solution of water and salt and salt with concentration of 0.1 kilogram per liter is flowing in at the rate of 5 liters per minute. The solution is well stirred and flows out at the rate of 3 liters per minute. How much salt is in the tank? How much salt is in the tank? Is in the tank. When the tank is full. Okay, let's draw a picture. See, we have a tank. The capacity is a 100 liter. Full capacity is 100 liter. Initially, there is 60 liter of water here. Initially. And there's some water flowing in and some water flowing out. Flow in happens with rate of 5 liter per minute. And flow out happens with the rate of 3 liter per minute. Flow in, the water that is flow in is salted water though. I want to make sure. Salted water. It's not pure water. Salted water flows in and then it's well stirred and then flows out. Now, let's forget about the salted water and the amount of salt for now. Just let's think about the water itself for the moment. So there is a 60 liter water in the beginning and the full capacity is 100 liter. Now in each minute, during each minute, 5 liter flows in, 3 liter flows out. So overall, in each minute, 2 liter water flows in. So first is 60 liter, after 1 minute becomes 62 liter, after 2 minutes becomes 64 liter, and so on. Well, ultimately the tank will be full and it will be 100 liter. We want to know at that time how much salt we have in the tank. So first of all, we can find out about the time at which the tank becomes full, because we just mentioned that first is 60 liter, after 1 minute 62 liter, after 2 minutes 64 liter, and so on. So first let's find out about the time at which the tank becomes full. So here is the answer. Based on the assumptions, during each minute, five liter flows in, 3 liter flows out. So overall, 2 liter flows in. So that means the amount of water after time t is given by V of t equals 60, which was the initial amount of water, plus 2t. T T here in minutes, I mean. The amount of water after time t is 60 plus 2t. Initially, at t equals 0, it's 60. At t equals 1 minute, 60 plus 2, or 62. At t equals 2, 60 plus 4, or 64, and so on. After t minutes, the amount of water will be 60 plus 2t. Therefore, the tank will be full. Full means 100 liters. If 60 plus 2t becomes equal to 100, that means 2t equals 40, and that means t equals 20 minutes. So we want to find the amount of salt in the tank, amount of salt in the tank after 20 minutes. So how can we do that? Let's set up an equation. Let's set up an ODE for the amount of salt in the tank. So now let x of t denote the amount of salt in the tank at time t. So first we need to assign a letter. X of t, we assume that x of t denotes the amount of salt in the tank at time t. So what is given to us and what is asked from us? We know that in the beginning, there is no so in the beginning is 10 kilogram of salt, right? In the beginning, there are 10 kilogram of salt in the water. So at t equals 0, the amount of salt is 10 kilogram. That's what is given to us. So given is that at t equals 0, 10 kilogram of salt in the tank. So that means x of 0 is equal to 10 kilogram. And what is asked from us? What is asked? It says that how much salt is in the water when the tank is full. But we just found out the tank will be full at t equals 20. So we want to find the amount of salt at t equals 20, which means we want to find x of 20, because x of t represents the amount of salt at time t. So it's asked from us to find x of 20 amount of salt at t equals 20. Okay, now setting up the ODE. But what is the rate of change of X? How fast the amount of salt changes? So rate of change of X, dx to dt is rate of change of X, which I can write it as rate flowing in minus rate flowing out. So this is the whole idea for solving this question, that we need to look at rate of change of X. Rate of change of a quantity means derivative of that quantity. So if I can find derivative of X, which is rate of change of X in terms of X itself, then I will have a first order ODE. And I already know how to solve the first order ODE. Okay, so for this type of question, the idea is very simple. Just assign a letter. If let's say amount of salt is asked at some time t, just assign a letter. Here we assume that x of t denotes the amount of salt at time t, and then set up the ODE. How can we set up the ODE? Just use the fact that derivative of a function is rate of change of that function. So dx to dt is rate of change of X. What is rate of change of X? It can be written as rate flowing in minus rate flowing out. What is the rate flowing in? Well, let's see. Flow in, 5 liters per minute flows in, and the water that flows in has the concentration 0.1 kilogram per liter. So this will be 5 liters per minute times 0.1 kilogram per liter. See, one way to verify that your answer is correct is that, see, dx to dt must have the unit kilogram per minute. So to verify your answer, you can look at the units. Do the units match in the left-hand side and right-hand side? In the left-hand side, the unit is kilogram per minute, because X I'm assuming is in kilogram, T I'm assuming is in minutes. This has the unit kilogram per minute. And this one has the unit 5 times 0.1. So this is liter per minute, and kilogram per liter. So liter cancel with liter. This one also has unit kilogram per liter times liter per minute, which is same as liter per kilogram per minute. So the units match. So this is for the rate flowing in, minus rate flowing out. Minus flow out, we have 3 liters per minute flow out. 3 liters per minute flow out. 3 liters per minute times, see, similar to the flowing in, I have to say how many liter per minute times how much kilogram per liter. How much kilogram per liter? Is that given in the question, how much kilogram per liter? It's not given in the question how much kilogram per liter flows out. It is given how much kilogram per liter flows in. but for flows out, it's not given. We have to find it ourselves. How much kilogram per liter flows out? But we are talking about time t, right? At time t, how many kilograms salt do we have in the tank at time t? Well, at the beginning, we know it's 60 kilogram. That's it at time at t equals 0. But what about at time t? How many kilogram do we have at time t? So to find this question mark above, note that at time t, the tank contains x of t kilogram of salt. See, we don't know how at time t how many kilogram of salt the tank has. That's the quantity that we assigned as x of t. We called it x of t. We assume x of t is the amount of salt at time t. Now, how much is x of t? Well, we know at t equals 0 is 60, but we don't know how much it is at t equals 1 or at t equals 2. That's what we actually want to find. We want to find the amount of salt at t equals 20. But the point is, we don't know how much salt we have at time t. We're just calling it x of t. So the answer to my question, how much salt do we have at time t? We don't know it as a number. We don't know which number, but we know that we have already called it x of t. So let's keep it as x of t. And it's okay to have x of t here because see, remember we are setting up ODE. ODE or differential equation, we said in the beginning of the course, means an equation that relates derivative of a function with the function itself. So if we can relate derivative of x with x itself, well, that's good enough. That means we already have an ODE and we can try to solve it. So note that at time t, the tank contains x of t kilogram of salt. So remember, to find this question mark here, this question mark, we need to know how many kilogram we have at time t. And what about the liter? How many liter do we have at time t? At time t, we have x of t kilogram. And how many liter do we have at time t? Moreover, at time t, the tank contains V of t equals 60 plus 2t liter. See above. This is what you already mentioned here, that at time t, the tank contains 60 plus 2t liter of water. So the question mark, see, we already found out how many kilogram we have at time t, which is x of t, and how many liter we have, which is 60 plus 2t. So to find this question mark, we just need to simply divide the amount of salt by the amount of water. So this question mark above can be found via x of t divided by v of t, which is x of t divided by 60 plus 2t. So we can say that dx to dt. Now let's substitute this question mark back here. Remember, we had dx to dt, flow in minus rate flow in minus rate flow out. Rate flow in, we already knew it. it was 5 times 0.1, which is 0.5, minus 3 times question mark. But question mark, we already found it as this. So 5 times 0.1 minus 3 times question mark. Question mark is x divided by 60 plus 2t. So that means dx to dt equals 0.5 minus 3x over 60 plus 2t. Now I can write this one as dx to dt, or I can call it x prime if you want. X prime plus 3x over 60 plus 2t equals 0.5. So this is a linear first order ODE, right? It's something of the form. Remember, we were saying y prime plus p of x times y equals f of x. Instead of y, here we have x. Our function here is x, is called x. And instead of x, we have t. Our independent variable here is t, which is time. So again, remember, it doesn't matter. Sometimes in ODE, we use x as the independent variable, y as the function. And sometimes, especially in physics, we use t as the independent variable and x as the function. So I hope that this doesn't confuse you. The concepts are still same. We're just using different letters. So it's a linear first order ODE with p of t here. P of t is 3 over 60 plus 2t. And f of t here is 0.5. So we have to follow the steps to solve the linear first order ODE. Okay, so the first step was finding integrating factor. Step 1, finding the integrating factor. R of t equals e to power integral p of t dt. So that's going to be e to power integral 30 over 60 plus 2t dt. And so if you want to find this integral here, to find integral 30 over 60 plus 2t dt, let's use substitution. Set s equals 60 plus 2t. Then ds will be equal to 2 dt. And then dt will be ds over 2. And then the integral will be 30 over s ds over 2. That's going to be 15 ln absolute value s. Plus a constant, but we said, we can just set the constant to be 0 for finding integrating factor. And then this is going to be 15 times ln ln absolute value. Well, here t is positive, right? So let's assume, because t is time, is positive. So 60 plus 2t will be also positive. So absolute value is 60 plus 2t, which is positive. So we can say 15 times ln 60 plus 2t. T is positive, so 60 plus 2t is positive. And so the integral will be r of t. If we find r of t, e to power this integral. Integral is 15 ln 60 plus 2t. Sorry, I made a mistake here. P of t was 3 over 60 plus 2t, but I wrote 30 over 60 plus 2t here. It's just 3 over this, so just delete this 0. Delete this 0, and then this will be, instead of 15, it will be 1.5, right? There's 3 over 2, which is 1.5. The rest is okay. And we can write this one as e to power ln 60 plus 2t to power 1.5. Power 1.5 means 3 over 2. And then e to power ln x is x. The basic identity you learned in pre-calculus. And therefore, this will be 60 plus 2t. (60 plus 2t to power 3/2). Right? So inside bracket will be 60 plus 2t, then raised to power 3/2. This will be our r of t here. So we can write the equation, our ODE can be written as d to dt of r of t times x equals f of t times x. Remember, this was the algorithm that we saw before. It seems my screen is freezed. Okay. So ROD can be written as d to dt r of t times x equals f of t times x. Previously, we were saying that r times y equals f times, f of t times r. Previously, we had r times y equals f times r. Here, instead of y, we have x. So r times x equals f times r. So that means d to dt of r of t, which is 60 plus 2t to power 3/2 times x equals f of t. F of t here is 0.5. So 0.5 times 60 plus 2t to power 3/2. And therefore 60 plus 2t to power 3/2 times x equals integral 0.5 60 plus 2t to power 3/2 dt. And therefore x will be equal to, okay, first let's find that integral. So to find integral 60 plus 2t to power 3/2 dt, we can define s again to be 60 plus 2t. That means ds will be 2 dt, or dt will be ds over 2. Then we'll have integral s to power 3/2 dt. dt is ds over 2. And then this will be 1/2 times s to power 5/2 divided by 5/2. And this is 1/5 s to power 5/2, which is 1/5 60 plus 2t to power 5/2. So if we substitute back, there's also extra coefficient of 0.5, 0.5 times this guy. We found the integral, then we need to multiply it with 0.5. So substitute back. Then we will have 60 plus 2t to power 3/2 times x equals 0.5 times 1/5 60 plus 2t to power 5/2, which is 0.1 60 plus 2t to power, and then we need to add plus c as well. You can include plus c. If you add plus c here, plus c, and then there will be plus c here as well. I have plus c. So x of t, if I multiply both sides by 60 plus 2t to power minus 3/2, then x of t will be 0.1 times 60 plus 2t. 5/2 minus 3/2 is 1, plus c times 60 plus 2t to power minus 3/2. Okay. And then lastly, to find c, use the initial condition. Use the initial condition, which was x of 0 equals 10. So x of 0 here will be 0.1 times 60 plus 0 plus c times 60 to power minus 3/2. That's going to be 6 plus c times 60 to power minus 3/2, and this is supposed to be 10. And this is one equation with one unknown only. So that means c times 60 to power minus 3/2 is equal to 4. And therefore c will be equal to, if I multiply both sides by 60 to power 3/2, c will be equal to 4 times 60 to power 3/2. So x of t will be equal to 0.1 times 60 plus 2t plus 4 times 60 to power 3/2 times 60 plus 2t to power minus 3/2. So this is the formula for x of t. This is amount of salt in the tank at time t. And the question asks us to find the amount of salt in the tank at t equals 20 minutes. Thus, the amount of salt in the tank when the tank becomes full, meaning that at t equals 20 minutes will be will be x of 20. And x of 20 means we have to replace t with 20, 60 plus 40. I'm replacing t with 20, 60 plus 40 plus 4 times 60 to power minus 3 halves. 60 plus 40 to power minus 3 halves. And if you use your calculator, you will see this is almost 11.86 kilogram. So it makes sense. Initially the tank had 10 kilogram of salt, and there was salt water coming in and stirred, and some part of it goes out. So after 20 minutes, it makes sense that the amount of salt is more compared to before, because salt water was coming in and some part of it going out, but overall the salt will increase as time passes. So it makes sense that, it's almost 2 kilograms more than the initial amount of salt. Okay, so this was an application of first order ODE. So this type of question, if you want to find the amount of salt at time t, you can just call it x of t, and then set up the equation ODE for x of t. Just remembering the fact that rate of change of a function is same as derivative of that function. So we found the formula for derivative of x, which is rate of change of x, as rate flow in minus rate flow out. And then we found a first order ODE for x. We solved that ODE using integrating factors. And then after solving it, we found the formula for x of t. Once we have the formula for x of t, we can find x at any t value. Here it was asking us to find x, or amount of salt, at t equals 20. We just simply replaced t with 20, and we found the amount of salt at that moment. Okay, guys.